Hey, what's up, guys? This is Chung here. So uh, today, today's daily challenge problem, right? Number 32, longest valid parenthesis. So this one, it's a very straightforward problem, but it has several like solutions. Basically you're given like a string containing only the left and right parentheses, and you need to find the length of the longest valid parenthesis substring. So for example, right, in example 1 here, we have 2 because that, and then in example 2 here, we have 4 because the middle 4 parentheses are the valid substring. And if it's empty, it's of course 0. So there are like several ways you can solve this problem. You can either use stack, and you can also solve it by using the dynamic programming. So let's take a look at dynamic programming, right? So for dynamic programming, the at a given location, at a given like index here, we need to find like state transition function. So actually, the way we define the state transition function is like this. We have dpi here, right? So dpi means that the longest, right? The longest valid string, valid parentheses, right? Parentheses, longest valid parentheses ending at I index. So basically that's the definition of the I here. So which means that this one actually is telling it means that the I's index has to be the I's string, right? Letter has to be a right parenthesis, because only the right parenthesis could give us like a valid uh, a pair, right? So if we define the DP function in this way, so how about the state transition function? So we have DPI. So how can we get the DPI from the previously state, right? So the easiest one is this. So we have two scenarios, actually, I think two scenarios. So the first one is that, if the Si minus 1 is the left parenthesis, right? So if the previous one is a left parenthesis, this one is pretty easy. Basically, the DPI becomes what? Becomes 2 plus DPI minus 2, right? So this is pretty straightforward, right? Because let's say we have several parentheses, and now we have a left and right. So this is I, right? This is I minus 1. We know that this one can definitely form a valid pair. That's why we can do a 2 plus DPI I minus 2. And then this is the I minus 2, right? Right. This because we're getting the longest valid string, right? Because if this one is like the valid one, then we can simply plus the previously state, the previously dp, which is I minus 2. So this is the first case, right? And the second case, of course, is the if the s I minus 1 equal to the right parentheses. So this one is a little bit complicated because so for this one, actually we need to use like the dp I minus 1 to help us find to come up with a state transition function. So let's say we have this one here. we have left, this one, right? So for example, if we have this one here, and this is I, right? And then the I minus one, is also a right parenthesis. So in this case, how can we uh, come up with the state transition function here? So basically, what we need to do is that we need to check, with I. Uh, so first we need to check. So be, with this I minus one, we have the dp I minus one, right? So the dp I minus one means that ending with this like position. What is the longest uh valid parenthesis, right? So in this case is what? So it's 1, 2, 3, 4, 5, 6. Actually, dp I minus one in this case is 6, right? So which means that we have like 6 valid parentheses from here to here. And then actually, so all we need to check is that we already have this one, right? So if we know if this one is a left parenthesis, because we already know that this part is 6, right? So and the oh only and then if we also know the previous one, like in which in this case is this one, is a left parenthesis, then we know, okay, so we have another pair, right, outside of this dp I minus one. Then we can just do the state transition here, because otherwise, if there's nothing here, if there's nothing, or this one is like is a right parenthesis, then we cannot form, basically ending with this I, we don't have any valid parentheses. Okay, only when we have like a left parenthesis, like a pair on the other side, then we know there's like a valid parenthesis, a valid like parenthesis ending with this I here. That's why the assuming that's the case, right? So the dp state transition function for the second case is going to be this one. dp going to be, first we have dp I minus one, right? Which is this part, and then we plus two, right? Plus two means this one. So we have the left and the right parentheses. Assuming we find the like find in on this position there's a matching left parentheses, and then we plus what? We plus the dp of I minus dp I minus one minus two. So what is the dp I minus one is this part, right? And then plus two is this left and right, and this one is here. This one is a dp. This index is the I minus dp minus one minus two, right? So that's how we get this the state transition function for those two scenarios. And cool. So let's try to code this dp solution first, right? So and if not as, we return 0, right? Else we have the length equals to s, and then we have a dp, right? So at the beginning, every place is everything is 0. If the answer equals to we don't need the answer in this case. So for I in range of 1 n, right? Because we start from second one, because we need at least 2 parentheses to form like a valid pair, right? So like I said, if the si is equal to the right parenthesis, this is the only case that we could possibly get a valid pair. And then the first case is that if the si minus 1 is equal to the left parenthesis, right? So this is the easier case. So in this one, it's simply just dpi equals to 2 plus dpi minus 2, right? Right. But be careful, since we do a I minus 2 here, if it's if this case, right? I mean, we're at I here, if we do I minus 2, it will be I minus 2 will become minus 1, right? So that's why we have to do a simple check here. We do this one if, right, if the I is greater than 1, else 0, okay? Else, right? So else means that, the previous one is also a right parenthesis. So in this one, we need to check. So if the si minus dp I minus 1 is equal to this one, right? And then we do this dpi equals to dp I minus 1 plus 2 plus dp I minus dp I minus 1 minus 2, right? But I think this one also have like an edge case here because, for example, this, we have this one here, right? So we're at I here. So this dpi minus 1, dpi minus 1 is 4, right? And the index for I is what? It's also 4, right? So 4 minus 4 minus 1 equals to minus 1. That's why so in this case, we also need to do a simple check here. So if I is greater than dp I minus 1 and, right? And this one we do this because, basically in this case, right, if there's nothing on the other side, we simply skip this, right? And in the end, we just return the max of dp, right? So this one here actually, so this is how we get the trying to get the corresponding position for the current one, because we have I here, and then we have dpi minus 1, right? So I minus 1 in this case is 4. So I minus 4 minus 1 is this one. Is the index for this one, and we just need to check if this one is a left parenthesis. Okay. Yeah. So if I run the code here, it's not accepted. Yep. So it passed, right? Yeah. Basically, that's the first solution, which is DP. And obviously the time and space complexity are both often, right? Okay. Cool. That's the first one. And the second one is that, if we don't use DP, we can also use stack to solve this problem. And so to use stack to solve this problem, actually, all we need to do is that, we just need to use a stack to track the starting point of the valid parentheses. Because, let's say we have this one, this one, this one, this one, right? And then we have this one, right? So as you guys can see here, so the first valid parenthesis is this one, and the second valid parenthesis is this one, right? And we need to somehow find a way to to know the starting point of this of each of the valid parenthesis string here, right? That's why, we can use a stack basically to keep track of the starting point of the of each of the valid parentheses. So the way it works is that, every time, you know when we have like a left parenthesis, right, we append that index into the stack. Okay. And And every time when we have like a right parenthesis, we first pop that in, pop from the stack. So okay, so basically this is how it works. So at the beginning we have the right parenthesis, right? So we're gonna have like a stack here. So the stack at the beginning it will be 0. Okay, and then for the second one we have 1 here, right? We have 1 here. So basically, you know, every time when we see like a left parenthesis, right, we push it into the stack. And then when we see a right parenthesis, we check if the top one of the stack is is a left parenthesis. If it is, then we simply pop it out because we find a pair for that, right? And then in the end, right, actually, so every time basically when we find like a pair of the current right parentheses, we can always look for the top one, of the stack, because the top one of the stack will always be the starting point, of the current valid parentheses, right? Because for example, in this case, you know, we push the right parentheses, of course the index into the stack, right? And then we push the left parentheses, and then we the second time when we have like a right parentheses, this one will be popped out, right? And then the 0, basically this 0 will be the starting point of the valid parentheses, right? So if we use the current index I, when we subtract the top one from the stack, then we have the valid string, right? And then again, the second time, another left parenthesis got pushed into here, which is the 0, 1, 2, 3, which is 3, right? And then the next one is 4, right? So the next one is the right parenthesis. So the right parenthesis, we see, okay, so the top one of the stack is like the left parenthesis, so this one is gone. And every time like I said, we find a pair, then we know after popping this left parenthesis, the top one, the top one in the stack will be the starting point. That's why we got like a 4 in this case, right? So again, if we have like another one, let's see if we have another left parenthesis in this case. So in this case, what we will have like this one. We'll have like 0, and then we'll have 1, right? We'll have 1, and then we'll have 2. 0, 1, 2, and now we have 3, right? So 3 we check. So since it's the right parenthesis, we check if the top one is the left parenthesis. It is. So we pop this one out, right? And then we have 3 minus 1, which is 2, and then 4 and 5 again, right? So we have 5. In the end, we have 5 minus 1. In this case, 1 is the starting point of that, of the starting point of the valid string. That's how we use the stack to track basically the stack. The top one of the stack will always be the starting point of the valid parenthesis string. And we also need to be careful with the corner case. Let's say if everything is valid, right? So in this case, you know, the stack will be empty, right? So to fix this, we can simply initiate the stack with a -1 at the very beginning. That can solve this corner case. All right, cool. So let's try to code the second solution, right? Which is the stack solution. So we have stack, like I said, we're gonna use the -1 to handle that corner case. And then we have the answer equal to 0, right? And then the for I dot c enumerate s, right? So if the current string is the left parenthesis, right, and then we simply push it right into the stack. Else means that it's a right parenthesis, and then we check if the stack is not empty and the top one of the stack is the left parenthesis. Since we're storing the index, we have to use the index to find the actual string, right? So if that's the one, then we pop it out, right? So after popping it out, now the top one of the stack will be the starting point of the string. So we have answer dot max dot answer dot I minus stack dot minus one, right? But be careful. So here we also have like a special case, which is the minus one, right? Because in this case, let's say we have this one here, right? If we have this one here, basically, hmm, so okay. Anyway, so basically here since we have a minus one, the minus one is it's not a valid index. That's why when we check this index with here, I'm also adding like another condition here, and the stack. This one where the top one is not minus one, right? And this one, then we can be sure, okay, that's the valid index, right? Else what? Else we also append, right? Append I. If we cannot find like a pair for the current right parenthesis, we're also gonna append the current I into the stack, and then in the end we also return the answer. So that's it, right? Okay, cool. So if I run the code again, so this one should also work. All right, cool. So stack solution also works, and as you guys can see, this one is also like O of n for both the time and space complexity, right? And so what else? Mm, yeah, so actually there's like another better solution which can give us O of 1 space complexity. And basically for that solutions, we'll be using like counters to count the left and the right parentheses. Actually, so for this kind of valid parentheses problem, it's a common strategy to count it, to basically to traverse this string twice. First time we traverse it, we loop it from left to right, and second time we loop it from the right to left. I think I have seen a similar problem for the valid. I think that's the valid substring, something like this. Basically, we loop through from left to right and then to right from right to left. So similarly for this problem, we can also do a traversal, do a loop from left to right. Basically, if we do it from left to right, we keep like two counters, like a left parenthesis and the right parenthesis, right? And so if we traverse from left to right, right, and then we just keep increasing the left and right parentheses, and every time when the left and right parentheses are the same, then we know we find like uh, a valid pair, right, of the parentheses string. And so, but how the question is, so when should we reset this left and right parentheses? So if we traverse from left to right, So we reset when the right parenthesis is greater than the left parenthesis, which is in this case, it's like this. So if we have this one, and now we have another right parenthesis. So now, so we have like a valid, we have a length of 4 valid pair, right? But then if we see another right parenthesis, now the right parenthesis is greater than the left parenthesis, so which means that no, the valid parenthesis stop here, right? So from here onwards, we have to basically reset the left and right parentheses because there might be another like valid parenthesis after this one, right? And that's how we do the left to right loop. So similarly, we also need to consider another scenario, which is this one. So let's say we have another one. For this case, in order to find this 4 here, we have to do the loop from in a reverse order, right, from right to left. And in this case, everything's the same except, so in this time, when the left is parenthesis counter is greater than the right parenthesis, we reset them. Yep. So I think that's the solution, the idea for the last solution. So we have a left parenthesis equals to right parenthesis equal to 0, right? And then we have answer equal to 0. So first we traverse from left to right. Okay. Current one is equals to Si, right? So if the C is the left parenthesis, right, we increase the left pointer by 1, right? Else we increase the right parenthesis by 1, right? So if the left parenthesis is equal to the right parenthesis, right, then we know we find like a match, which means that we're gonna do a max of the answer of the 2 times either left or right works, it's okay. And then we reset if the right parenthesis is greater than the left parenthesis, right? Cool. And again, right, so we reset one more time before traversing from in a reverse order, right? So I think I can pretty much copy that everything, except I just need to change the other condition, the for loop condition, and then here, right? So left to right, and then return the answer. Yeah, so that's gonna be the last solution here. So if I run the code, yep, so it works, right? So the last solution, we only have 2 for loops, so time is still O of n, but space is O of 1, since we're only maintaining 2 variables here. Yeah, cool. I think that's everything. I think for this problem, we introduced 3 solutions, right? I think for the DP one, it's a little bit tricky because there are like a bunch of scenarios you have to be considered. I think the second one is the most straightforward one, since we just need to use a stack to keep track of the starting point of each valid parenthesis string. And the last one requires a little bit experience. Basically, we have to be able to know for this kind of valid parenthesis problem, we always do a 2 loop, one from left and one from right. Okay, and then during the loop, we keep track of 2 counters, and then we update the answers when the counters are the same, and then we reset based on different conditions. Cool. I think I'll just stop here. Thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.